Good morning. Today I am presenting my research work on a pre-factory analysis of brain-computer interfacing based on EEG signals, and I am Ayonija, pathre, research scholar in computer science from Rabindranath Tagore University, and Dr. S. Vinadhari. She is in associated professor in Rabindranath Tagore University. And abstract. This is the abstract of my research work. My research on uh, EEG signal. My research on basically is EEG signal. What is EEG signal? EEG tracks and records brainwave patterns through a small metal disc with thin wire electrodes are placed on the scalp and the send signal to a computer to record it the result. And BCI is a system. It plays an important role between human brain and EEG. BCI is a brain-computer interface establish a direct function between a human and external device. I have read many papers. I find out uh, different kind of challenge. There have been several difficulty in developing the interface of communicating using brain signals. It is possible to identify them as techni- technological and functional. The technological difficulty are related to the device barrier, especially those related to EEG signals. And objective of this paper is to develop a classifier that can correctly identify whether a subject is visualizing a task that is familiar or unfamiliar to enhance prediction accuracy and reduce loss value, including validation. Motivation, a extremely developing area of application system science is defined by brain processing interface technology in health field. It contributes range from treatment of synaptic healing for several injuries. Deep learning has already received mainstream recognition and has been used in numerous applications like language processing, computer vision, and voice. In this paper, highlight the field of application that could advantage for brainwave in promoting or attaining their objective. We also answer big usableness and technological problem facing the use of brain signal in different BCI device component. This is the proposed methodology. Here, I will use CNN model. CNN model, it consists of 5 layers. First layer, first layer is especially designed to capture the spatial feature characteristics of EEG signal. Next two layer is a convolution layer. Is mainly for the spatial feature extraction. It perform a extraction on the feature. Yeah, here we will use a one-dimensional convolutional filter in the first convolutional layer for better analysis of spatial feature. Last two layer is fully connected layer, and in this layer we use the softmax layer or softmax function. These two layer mainly perform the classification task and to prevent the model from overfitting, and we will implement dropout regularization before the dropout layer. This is the proposed model diagram. This diagram follow the 8 layer concept and process the model activity and eight layer different kind of 8 layer. The input to the model is RGB image. It has here in this model we give the input in a five. We give a input in a RGB image, and then it has three fully connected layer. The activation function used in all layer Here we use ReLU activation function. It used to dropout layer. The activation function used in the output layer is um, softmax function. This is a proposed algorithm. This algorithm will understand through this flow diagram. Here we can start. Uh, Here we can use for implementing this model. We use the Python or MATLAB. After the uh, pre during the pre-processing, we use the usable data, and we remove the inefficiency or unreadable data, and we can generate a CSV file. This CSV file is again split into 250 different type of CSV file. Each CSV file consists 28 per image, and after the generation of this image are passing to the model, and after generating the image interpreting and remove the error. After this image provide to the LXNext model. After this model for the training and validation, and then we are getting the our prediction, and this algorithm will be end. This is the conclusion of my paper. Here we use the deep learning method identify focal EEG signal is suggested in this context, minimize overfitting and enhance classification accuracy established. In this paper, we suggest the DL algorithm for EEG pattern classification. Uh, or here we are work on the space frequency spatial feature extraction method, and multiple layer on LXNet model is developing. Thank you.